right, so usually every time I do a talk on chaos engineering, I have some sort of laptop issue. It's the universe trying to mess with me. So thank you all for having me here today. I'm really excited to be at Monitorama. I've been meaning to make it to this conference for many years, and this is my first time here. And I'm super excited to talk to you all today. John gave an excellent talk, and I'll be covering some of the same topics, but relating them sort of to chaos engineering. So chaos engineering borrows ideas and theories from several different industries. There's many industries that do resilience engineering, simulation performance, and learning science, and sort of game day type exercises. This talk was inspired by a lot of people, and I particularly liked Logan McDonald's talk last year at Monitorama on optimizing for learning, where she shares some personal experiences she had with learning systems more deeply in building up that adaptive capacity to handle situations. She says in her talk that being open to learning is critical, and that really stuck with me. Today I'm going to talk about how optimizing for learning can be applied to organizations through chaos engineering and some things to watch out for in the meantime. So you might be wondering, how does this relate to observability? When I'm talking about observability today, I'm going to use the definition from Joint Cognitive Systems by David Woods and Eric Holnagel. They say observability is feedback that provides insight into a process and refers to the work needed to extract meaning from available data. So observability means a lot of different things to a lot of different people. If you Google what is observability, you will get hundreds of Google links with people arguing over the definition of it. I think really what we can all agree on is we want to use it to learn, right? We want to use it to be better. We want to use it to build up expertise so that we can understand our systems better. So a question I have is, how can you distill know-how and expertise through chaos engineering and use that as a tool? John mentioned in his talk that you can use incident analysis as a tool, right? Incidents are expensive. Maybe you can actually see when your teammates have different mental models, or you can learn more about your system through this pre-planning, through chaos engineering. So I want to use today to talk about one of the most famous chaos experiments or simulation experiments blunders I know. This is not Chernobyl, even though that's been popular as of recently. It's the Apollo 1 launch rehearsal test. So Apollo 1 was the first crewed mission of the United States Apollo program. The Apollo program is a well-known, and it's responsible for landing the first humans on the moon. The launch rehearsal test for Apollo 1 was planned as the first test of the Apollo Command and Service Module, with a crew set to launch on February 21st, 1967. Unfortunately, that crew never actually flew. A fire in the command module broke out during the launch rehearsal test on January 27th and killed all 3 crew members that were set to fly out. The name Apollo 1 chosen by the crew was officially retired by NASA 3 months later. Essentially what happened is the ignition of the fire in the cabin was contributed to by vulnerable wiring carrying spacecraft power, vulnerable plumbing carrying a combustible corrosive coolant, and a number of other things. The rescue of crew members was prevented by this plug door hatch, which was actually thought to keep them safely inside during flight. But it could not be opened due to the higher internal pressure of the cabin. And I'll talk more about this later. Since the rocket was unfueled, the test was not considered hazardous to begin with, and it was thought that the blast radius of this experiment was effectively mitigated. As a result, there were standard emergency preparedness procedures that did not actually take place, and they were deemed unnecessary prior to the test. So emergency teams such as fire, rescue, and medical were not notified of any of the risks in this test and were also not in attendance. This event was not only tragic, it embarrassed NASA, and it was an example of an experiment that went wrong, and it's a good reminder of attention that can be placed on these experiments. This event ended up changing spacecraft design forever. Now, not all of us in software are directly dealing with human lives, but we all do work at companies that are running businesses, ideally generating real revenue. Incidents can be detrimental and costly for a number of reasons, and part of that fact is why we practice chaos engineering in software and use it as a way to build confidence in our systems and our ability to react to failure. I'll be referencing this case throughout my slides today. So I'm Nora Jones. I currently work at Slack, and I've been involved in risk, operations, and reliability worlds for a while now. I was on the chaos engineering team at Netflix and wrote a book with my colleagues about the discipline and how we used it at Netflix. Being a software engineer working on the chaos team in Netflix kind of evolved into me asking deeper questions around how are these vulnerabilities that we're finding through chaos engineering coming to be? How do they relate to incidents? And how can we learn more about how teams work? I developed this very weird expertise of understanding all the patterns in our system that were revealing vulnerabilities. And so I started digging more into that by looking into incidents as well. And that guy that was just on stage, John Allspot, convinced me to do this master's program where I look into human factors and system safety as well. And it's completely opened up my eyes to this whole new world of things that we can dig into in software. I've gotten to do this at 2 different organizations now, and at Slack I'm doing similar things. I'm actively working and researching how to connect and draw parallels between these 2 worlds, human factors and chaos engineering. So I want to lead into this traps talk by saying we can use chaos engineering as a way to build adaptive decision-making capabilities in engineers. And this isn't the only way we can do this. As mentioned, we can also use incident analysis, right? Chaos engineering experiments can allow us to identify gaps in our system, and we can use that knowledge to actually help build people up. With this primary goal in mind, there are practices that I see within chaos engineering that can detract from learning. The most powerful monitoring tool is the human, so let's build up that expertise. So with that in mind, let's go into the 8 traps of chaos engineering. Through this unique lens of seeing chaos implemented in a few organizations, it's led me to find 8 traps of chaos engineering, and I've based this partially off of Johan Bergstrom's 3 accident investigation traps talk, which I would highly recommend viewing. And although the Apollo 1 story is tragic, it reveals a lot of chaos engineering traps that I see play out in software today, and ones that I have myself been a part of and learned from. Now, not all of these traps will be relevant to the Apollo launch experiment itself, but I'm going to draw parallels where I see them. And I realize this reads like a 2011 BuzzFeed article, so I'm going to lean heavily into it and say you won't believe trap number 3. So trap 1, you can measure your success with chaos engineering by counting the number of vulnerabilities you find. I think this is a really easy thing to do when you're starting out with chaos engineering, because it's one of the first things that you can grab onto. It's very common and it's a very natural way of measuring ROI, but it doesn't actually tell you anything about how you're doing. I want to share a quote from The Error of Counting Errors by Robert L. Wares. He says, "You don't know much about safety simply by counting errors." And he also says error counts are measures of ignorance rather than risk. And swap out errors for vulnerabilities or incidents here, and you have the same thing. You really don't know much about safety and about how you're doing as an organization just by counting these. I want to share a story on finding vulnerabilities. You may find yourself in a situation where management wants you to prove out that chaos engineering is working and that you should invest in it as an organization. I was on a team once that had this OKR imparted on them to find 200 vulnerabilities in a quarter. I mentioned this goal to another colleague in the organization on a different team, and he was like, "You're getting measured by finding vulnerabilities?" He's like, "I can easily help you with that if you're short on vulnerabilities at the end of the quarter." I know this great JavaScript repo. It's still being used. No one knows how it works, but it's definitely going to fall over any second now. And I was already kind of skeptical of this OKR, but that's when it really hit home for me that counting vulnerabilities doesn't really tell you much about the success of the chaos program. It doesn't really tell you if you're building people up. Which leads me to this book I found called How to Lie with Statistics. It was written in 1954, and it still holds up incredibly well today. It illustrates outlining errors when it comes to the interpretation of statistics and how these errors may create incorrect conclusions that lead us to believe that we're performing better or worse than we actually are, right? All graphs, all timelines are actually opinions. Who's seen a graph like this before? Anyone? I've seen it everywhere. Counting number of incidents, right? And it's not always related to chaos engineering. It's related to a lot of other stuff too. It's like, okay, we had a lot of incidents last quarter. Now we did a bunch of stuff, and now we have less. As an engineer, I see this. I think, if that's what I'm getting measured on, maybe what I did wasn't an incident. And that's what it leads to over time. It leads to people not reporting differently. It leads to people using these reporting systems differently. This right here doesn't actually tell you much of anything about how you're doing, right? But I've seen people try to attribute this to chaos engineering successes. And there are a lot more ways that we can learn how we're doing, right? This is a way that we easily grasp onto, but there's more. And so the goal of chaos engineering isn't to simply find vulnerabilities through tooling. The goal is to push forward on a journey of resilience through the vulnerabilities we find and share them with people and dig into them like you would an incident. I would advocate for holding something similar to an incident analysis when you do find a vulnerability, or even when you don't. Resilience is the ability of a system to adjust so that it can sustain normal functioning in the face of changes and disturbances. And when I say system, I don't just mean the tooling, I mean the people too. Knowing how we react in situations in the faces of these disturbances is part of chaos engineering. So capturing how your teammates are reacting, not just the experts on the team, but the whole team is working together to mitigate this issue and to understand this vulnerability more is important to capture in the report that you send out afterwards. The humans, the attitudes, and the trade-offs that they're making under pressure are all contributing factors to how the system runs. And you can capture some of this through doing chaos engineering before you have an incident. It's not a means to an end for achieving resilience or proving resilience, but it's a tool that you can use in the process. And this leads me to say, looking at what went right in a chaos experiment actually helps us understand what went wrong. And Sidney Dekker says, the pursuit of success, what did we learn we're really good at? Most of the time in chaos engineering, we focus on what didn't go well, right? That's why we set up these chaos experiments a lot of the time is we're not really sure what's going to happen. And as in the report that you send out afterwards or even disseminating the learning, putting what you actually did well at is important to building up that learning in the organization. So trap number 2, not all the people that work on the service need to be involved in the experiment and preparation. Now, this is really hard to do in practice, but I see it happen all the time. There's a one-on-one meeting, you meet with usually the most senior person on the team. They tell you what's supposed to happen, but that's a huge miss. I've seen something play out where 2 out of the 11 engineers were invited to the preparation meeting. And this was done to save time because it's expensive to have all these people in a room. And it's like, they'll all be there for the actual experiment. But I would argue that the preparation is maybe more important than running the experiment itself, because it reveals a lot to you about what's about to happen and what people think are about to happen. This deserves a lot of dedicated time and attention, in my opinion. And although it might take a while, the value will show itself after the first couple times. I've been in a situation where everyone comes ready to do a game day, but only 2 out of the 11 people know what's going on, right? And so now you're missing out on the mental models of 9 people on the team that have different interpretations of how the system works. And you're also missing out on the rich discussion that comes out of it. As someone that's facilitating chaos experiments, you're going to see that discussion play out. And as John said, disagreements are data. They're also data for doing this. So trap number 2 in the Apollo 1 launch experiment, not all the necessary parties were involved in the design of the experiment, like rescue team or medical assistance team. Essentially, they weren't thought to be necessary, but they were necessary in the actual launch. Trap 4, chaos engineers should be rule enforcers. You shouldn't be a rule enforcer. Your job as either someone creating the system for chaos engineering or facilitating experiments or being this expert is not to be a rule enforcer. It's not to chase people down to fix these vulnerabilities when you find them. Part of the success in chaos engineering is to actually build relationships. You don't want to be seen as someone that can assign work to people, because they're not going to want to work with you after that. You know, that you want to be able to be an open party for them to share their thoughts about their system, to share their mental models of their system, and have an open discussion. Now, tools can aid this, but you really do still need people in this process as well. And this person should understand the trade-offs that people are making under pressure, right? They should ideally be an engineer themselves. Expertise, understanding it, distilling it. So requiring people to fix the vulnerabilities you find doesn't actually end up helping, ever. It often harms relationships and can be thought of as infantilizing. Imagine, assigning work to someone for a system that you're not really even a part of and not doing the work for. It's the same with action items and incidents. Instead, I would suggest bringing context on a part of the system that the service owner may not have been previously aware of through running this experiment. But don't take control over whether it gets completed or not. So anyone who's in ops, SRE, or a non-core service owning team can relate. I'm sure all the folks on these types of teams have been in a situation where they're supposed to pile these action items on for people and supposed to be responsible for getting them done. And it's not fun for anybody. Trap 4.5, you should fix the vulnerabilities you find, and if you can, automate the fixes. It's not always beneficial to fix the vulnerabilities. I mean, I think all of us sitting here today can think of vulnerabilities in our systems that we're actively not fixing right now. We're choosing to do other things instead. When I was at Netflix, we wanted to automate some of the fixes for the vulnerabilities that we found, right? There were talks about that. We could see vulnerabilities in the process, but then we thought, if we do this, who will have the expertise on the vulnerabilities that we're finding, right? We were finding vulnerabilities related to timeouts. And if an automated system was automating these timeouts for customer behavior, when that inevitably broke at some point, who would contain the expertise on what was supposed to happen in that situation? The system, the service owners, the people that developed the chaos tools? Really, no one would have that expertise, and it would lead to some turmoil during an incident. So the Apollo 1 crew expressed their concerns about their spacecraft's problems by presenting this parody of their crew's portrait. And it is very sad, but this was their way of bringing context to him. They wrote on the back of the picture, "It's not that we don't trust you, Joe, but this time we've decided to go over your head." Trap 5, it's not real chaos engineering unless you move beyond game days and experimenting in non-production environments. These two things, practicing game days and chaos in a QA or a staging environment, are not only immensely valuable, they're also completely necessary before experimenting in production, and even while you're experimenting in production, as a means of learning, as a means of understanding your system, as a means of working with your teammates and creating this situation with low risk where you can actually learn things. I've seen a lot of good come out of both of these things. It's definitely different, but it's good preparation. And you can still do these things when you are moving into experimenting in production. So when I was at Netflix, we had this system called CHAP. It was a chaos automation platform. And it allowed the ability for service owners to create and run their own experiments. But what we ended up finding was that we on the chaos team were still the ones doing it, even though we had this tooling. So we decided to automate the creation and running of experiments. And this took a couple months to design this, right? We wanted to automate creating the experiment and all the factors that went into it. So we gathered information on timeouts, RPC calls, retries and fallbacks, percentage of traffic things served in order to prioritize these experiments and understand how important they were to run. But what we found as we were aggregating all this information and going through the process of trying to automate the creation of these experiments, we realized that a lot of this information was in a bunch of different places. And so we aggregated all of it, and we were like, well, the goal here is to automate experiments, but maybe there's a lot of value in putting this up for people to see as well. So this is in a paper we recently published for the ICSC, but we took all this information and we aggregated it. And all the necessary data that was shown here to automate these experiments was available somewhere in the system, but it hadn't been organized and represented to capture these patterns, to capture when people didn't have logical timeouts or logical retries or their percentage of requests all in one way. People instead had to read and integrate each piece of data to make this overall assessment, and which meant they largely never did. There was no reason to ever do this, so most people didn't until there was an incident. And so this UI was actually a direct result of going through the preparation for automating experiments. It was never our goal to do this, but it ended up being more enlightening than actually running the experiments themselves, was having this ability to look at these services within a system and to see, is this safe to fail? How does this work with the percentage of requests? What are the logical timeouts in this situation? What are the logical retries? In Gary Klein's world, we can see pattern recognition as a primary means of distilling expertise. And that's exactly what we were doing with this UI. So I'd argue that you can get more value going through the process of automating chaos experiments or even running chaos experiments than you can actually automating them or running them. We learned so much more by going through this process than the results of the actual automation showed us, even though the results were strong too. Trap 6, the most important part of chaos engineering is running the experiment. So like I was saying, creating the experiment and knowing what to fix are arguably the highest returns of investment on chaos engineering. And showing these things to teams and distilling information, the value we got out of going through the process of creating the experiments was more than the value we got out of running them. I would recommend placing unique attention on each of these phases, before the experiment, during the experiment, and after the experiment. I don't have time to go over what you should do during all of these phases today, but I will talk about the before phase a little. And I'll share a quote by George Box here. He says, "All models are wrong, but some are useful," right? Disagreements between teammates are data. Disagreements about how the system is supposed to work is data because it's teaching you how you work. So here's a few recommended prep session questions to ask. As a facilitator or as someone building up this expertise is which behaviors and interactions are you concerned about on your team, and how does this vary among teammates? How are you deciding what to experiment on? And that's telling and should be captured in the report as well. How long does it take to onboard a new engineer? If you ask a team that, capturing their answer is important too. And what do they do to onboard new engineers? What do you assume your teammates know about the system, and how do you feel confident that they're good to go on call for that system? And which code paths haven't been executed in a while? This last one you can ideally get through looking at your system, but it's also good data to actually ask the team as well and see what they say. Eliciting questions about people's mental models will lead us to be better storytellers and to distill this information to the rest of the org. So who here has used Console before? Who's seen it used in a really odd way? So it's a great piece of infrastructure, and it's so great that I think people end up over-indexing on its greatness. And so I'm using it as an example today, but really you can substitute this for anything. Incidents are an opportunity for us to sit down and see how person A's mental model differs from person B's mental model. And so, for example, person A thought that they could expect 100% uptime from Console, whereas the architect of Console, person B, assumed that users of Console would never even make this assumption, right? And so they never had that conversation because they both just assumed something about the other person, right? The assumptions made by both parties were completely reasonable given the context that each of them had about the system. So the operator assumed that no one would ever expect 100% uptime from anything, but the person that had been using console for various things and had seen good come out of it kind of thought it was this magical black box. And it worked well up until the day that it didn't. And so that's where chaos experiments can come in so that you can find that out before an incident happens, right? You can experiment on shutting down critical pieces of infrastructure in some way or simulating that shutdown and seeing, who cries wolf. The chaos experiments serve as a chance to find vulnerabilities in our systems, yes, but even more importantly, they serve as an opportunity to see how our mental models differ and how our organization works. The designer and facilitator of the experiment should ideally be someone from outside of the team to navigate and understand the biases of the team members that may carry out this system. They facilitate the conversation, they ask questions, and they state their opinion, and then they aggregate hypotheses about the system, similar to when you're doing an incident analysis. Trap 7, you can worry about safety later. The important part is creating the chaos. Especially when you're first implementing chaos engineering, it gets exciting to say, yeah, we're doing it, we're shutting things down, right? We'll figure it out later, right? That's the hard part, right? Creating the chaos is easy. I can shut things down. I can, throw random exceptions in places or make, my sleeps incredibly long and see what happens. But talking about safety includes people as well. Plan out the experiment, talk about who should be in the room, talk about what could happen if something goes wrong and who will be on point monitoring it. I would recommend having actual specific roles during it too, like a scribe, a facilitator, someone monitoring, someone watching a channel where incidents get posted in. Apollo 1 on Trap 7, just how vulnerable are defenses we put in place. So that plug door hatch that I was talking about earlier that was meant to keep the astronauts' safety inside during spaceflight was too hard to open during this launch test due to internal pressure. It's ironic that something that was designed to keep you safe led to a catastrophic failure, but that's not uncommon, right? Richard Cook refers to these as vulnerable defenses, which is something that we can use chaos engineering to test as well. The defenses we put in place are themselves vulnerable, and they need to be tested too. Like, think about vulnerable defenses you might have, like a rollback button. Maybe you haven't had to roll back in a while. Does that button still work the way that you intend? It's important to understand that the defenses that we put in place. Chaos engineering can help shed light on some of these vulnerabilities. So this is a common trap to get into and get excited about. But it's worth more to put more time into this and to understand the blast radius of the effects because it will help you learn more as well. So this is Gus Grissom, who was a crew member during the Apollo 1. He said, you sort of have to put that out of your mind. There's always a possibility that you can have a catastrophic failure, of course. This may happen on any flight. It may happen on the last one as well as the first one. So you just plan as best you can to take care of all these eventualities. And then you get a well-trained crew and you go fly. The Apollo 1 incident actually occurred a month after this interview, which killed Gus Grissom and both of his crew members. And again, this is very tragic, but safety is something that we have to keep in mind from the beginning, and we have to define what that means in our organizations as well. Trap 8, you can do chaos engineering without having an understanding of the system you're experimenting on. This isn't a plug-and-play model. Any tool you have in place, whether it's purchased, whether it's homegrown, should be facilitated by experts in that specific system. And by system, I mean the company in general. You'll be shooting in the dark without understanding things about your system, traces, incident patterns, et cetera. I want to share this quote from Gary Klein again on novices versus experts. He says, the new employee should can see the times when the system broke down, but not the times when it worked, right? Which is why it's important to have people in the room that understand the system. Don't make this an intern project. It's important to have folks that are considered experts in the system in the room as well as all levels of employees. I was on this team at a company where the first project I worked on was a chaos engineering project. And I was given this project. We had been having a bunch of incidents recently, and I created a tool that came up with eligible services to shut down, a chaos monkey of sorts, and I sent an email out to folks, and I said, these are the services that are eligible. Tell me if you have any concerns. We're going to start between 9 and 5 in 2 weeks. So I waited, and I didn't really hear anything. And then I sent another email, still didn't hear anything. So I started going up to teams. They're like, it's fine, we don't have time, it's okay, like, it's just in QA. And so I assumed that all was good to go, and I released Chaos Monkey on some of these services, and it took down all of QA for a week. And we learned a lot. We certainly learned a lot there, right? We learned a lot about our system. We treated it as a post-incident. But it should probably not be a project given to a new hire, a project given to an intern. As Logan McDonald said in her Optimizing for Learning talk, have low-stakes ways of learning, right? So trap 8.5, it's okay to be a little lenient about the definition of steady state. So on principlesofchaos.org, it indicates, start by defining steady state as some sort of measurable output of a system that indicates normal behavior. The Apollo 1 launch experiment on steady state. The morning of the test, the crew suited up and detected a foul odor in the breathing oxygen, which took about an hour to fix. Then the communication system acted up, shouting through the noise Grissom vented, how are we going to get to the moon if we can't talk between 2 or 3 buildings? The steady state was not exactly in a good place the morning of this incident. And trap 3. There is a prescriptive formula for doing chaos engineering, which is why this slide is out of order. There's no template you should use when conducting game days, much like conducting incidents. There are pieces of advice that should be followed and a science that can be applied, but you can't have a prescriptive formula when you're talking about the unpredictable and when you're talking about learning as well. It'll pigeonhole you into a particular thing. I hope you come away from this thinking about the perspective and the approach and not the prescription, and eschew the idea that there's a one-size-fits-all template that you can apply to chaos engineering as well as incidents. The more we talk about this and the more we learn about it, the better we'll get at it. If we can be aware of these traps, we can be aware of using alternative strategies instead. And so now back to my 2011 BuzzFeed article, you won't believe trap number 3. I hope you come away from this understanding more about how the tools we use can build expertise in our systems, but how these tools can sometimes be misused as well. Thank you.